Ladies and gentlemen, please take your seats. Our program is about to begin.
Ladies and gentlemen, our program is about to begin. Please silence your cell phones or place them on vibrate.
أيها السيدات والسادة، سيبدأ البرنامج بعد قليل، لذا نرجو منكم التكرم بالجلوس في مقاعدكم.
Hello, everyone. Good afternoon. It's a great pleasure for me to introduce Professor Jonathan Foley, joining us virtually today to present Achieving Drawdown, a hopeful science-based plan to address climate change. Dr. Jonathan Foley is a leading climate scientist, sustainability expert, educator, and public speaker. He's also executive director of Project Drawdown, the world's leading resource for climate solutions. His works focus on finding solutions to sustain the climate, ecosystems, and natural resources we all depend on. Dr. Foley's work has led him to become a trusted advisor to governments, foundations, nonprofits, and business leaders around the world. He and his colleagues have made contributions to our understanding of climate change, the global food system, and the sustainability of the world's resources. He has published over 140 scientific articles, including many highly cited works in Nature and Science. He earned his PhD from the Department of Atmospheric and Oceanic Sciences at the University of Wisconsin and is among the top 1% most cited scientists globally. A noted science communicator, his presentations have been featured at hundreds of venues, including the Aspen Institute, the World Bank, the National Geographic, and many more. He has also written many popular pieces in National Geographic, the New York Times, The Guardian, and Scientific American. Dr. Foley has won numerous awards and honors, including the Presidential Early Career Award for Scientists and Engineers, awarded by President Clinton, the J.S. McDonnell Foundation's 21st Century Science Award, an Aldo Leopold Leadership Fellowship, the Sustainability Science Award from the Ecological Society of America, and the National Science Foundation's Faculty Early Career Development Award. He was also named as the winner of the prestigious Heinz Award for the Environment. Please join me in welcoming Professor Jonathan Foley.
Thank you, everyone. It's really a pleasure to have opportunity to speak to you today. I really appreciate it. So we'll be talking about this idea of achieving drawdown, or different paths to stopping climate change, and how we're going to be looking to the future of addressing this incredibly important issue. But as we think about the future, sometimes it's important to look at the past and understand how we got to this place of a global climate crisis. As we think about this kind of future, though, one of the things that we can keep in mind is how the world has changed, especially in the last few decades. The world has changed throughout human history. Since we began our evolution of this planet, humans have been modifying the environment and changing things. But in the last few decades, we've really accelerated our impact, largely due to a couple of factors. One, of course, there are more people in the world. Two, we've become an urban species with much more infrastructure than anybody in previous human history. But most importantly, we've had a rise to a truly accelerating global economy, fueled by technology, trade, international travel, and so on. And during the last 50 years, we've seen about a doubling of global population, but the economy, adjusting for inflation, grew nearly sixfold during the same time. Combined, that drive of economic growth and some population growth has meant that the world's food demand has roughly tripled, our water demand has roughly doubled, and fossil fuel combustion roughly tripled as well. And that means just in 50 years, we've changed more than not only any other period in history, but all human history before us combined. And this is obviously having an effect on the planet, not just at a local scale, but at a kind of global scale. For example, we see that rainforests all over the world are being cleared largely for commodity agriculture and animal agriculture. Here showing places in the far reaches of the Amazon being cleared. And today we see about 30% of our tropical forests have already been lost. We also see, of course, that we have manipulated water in many places in the world, in many ways very unsustainably. Here's an example from Central Asia, where the Aral Sea was no longer being fed by rivers that naturally fed the Aral Sea, because those were diverted to irrigate cotton in the deserts of Kazakhstan. And today, this is what the Aral Sea looks like. And water resources are also collapsing in many parts of the world due to unsustainable overconsumption. But perhaps the most important thing we've done to the planet is change the nature of our atmosphere and even our oceans, and changing the world's kind of physical climate systems. We started doing this a while back, really in the 19th century is when this started to really get going, but it's accelerated greatly in the last few decades. Here showing the rises of CO2, just one of the greenhouse gases causing climate change. And note that those levels have increased by about 50% since the beginning of the Industrial Revolution. During that same time, though, the planet has warmed roughly 1 degree Celsius, a little bit over that now. And we see how the warming is kind of keeping pace with the increasing levels of greenhouse gases. One interesting thing to point out is the first scientist to ever really write about increasing CO2 and warming was at the beginning of this graph. A woman named Eunice Foote was the first person in 1856 to write about increasing CO2 and causing climate change back in 1856. And so this American woman was really the first scientist on Earth to really describe what we're seeing today, almost 170 years ago. Well, as we think about the future, though, of climate change, unfortunately, we seem to be in a place where a lot of people feel that it's almost hopeless because we've seen so much warming. We've done very little about it in many ways. And I wouldn't blame people if they said, this seems kind of hopeless. We're really in a big trap right now, a really big mess. But I don't see it as hopeless, actually. I think that we can still build the future we want. We have many choices ahead of us. We have many tools in front of us that can still stop the worst of the climate change ahead of us from getting worse than it is now. And we believe that it's possible to stop climate change and to do what we call achieve drawdown. Well, what does that mean exactly, achieving drawdown? The idea here is that greenhouse gases have risen considerably in the last century or so, and we have a choice to make. Will they continue to rise, going up and up and up, causing the planet to warm, further destabilizing our climate patterns, weather patterns, agriculture, water, health, etc.? Or do we change the future? Do we maybe bend that curve into a better direction? We hear that phrase a lot with the pandemic, but we need to do it with the atmosphere as well. So how do we stop the rise of greenhouse gases and stabilize them and maybe even bring them down again? Well, once we do that, when we can possibly do this, we'll hit what we call the moment of drawdown. Drawdown is a point in time in the future when the levels of greenhouse gases stop climbing and they can start to steadily decline later. And that will thereby stop future climate change from happening. To do that, though, we have to work on a number of different fronts because greenhouse gases include many different chemicals. The predominant one is carbon dioxide, but we also have to worry about methane, nitrous oxide, and a family of other gases that we're increasing in the atmosphere. And these come from a variety of different things. Of course, burning fossil fuels, primarily coal, oil, natural gas, and so on, is the single largest cause of the greenhouse effect that we're adding to the atmosphere. About 60% of climate change today is being caused by CO2 from fossil fuels. But we have a few other players as well. For example, CO2 coming from cement and industrial chemicals that have nothing to do with fossil fuels. That's important. Deforestation is also very important. Burning trees is not that different than burning fossil fuels. They're both made out of carbon and release carbon dioxide to the atmosphere. Interestingly, deforestation and land use is about 11% of global emissions today. The United States, by comparison, is about 12% of global emissions. They're roughly equivalent to a very large country here. We also have methane, another powerful greenhouse gas that comes from the energy industry, leaking natural gas, pipelines, abandoned wells, and so on. But also methane comes from biological sources, primarily in agriculture, from ruminant animals, especially cattle, but also a little bit from rice fields. We also have nitrous oxide, another chemical that goes in the atmosphere, N2O, which comes from a little bit of industry, but primarily agricultural fertilizers. And then we have a little kind of family of gases called F gases, which are mainly used as refrigerants and other kind of industrial chemicals today. And those are increasing as well. So those are kind of the reasons we have to think about the energy sector very, very much, anything that kind of orange color. But we also have to think about land use and agriculture when it comes to climate change, as well as materials like refrigerants and cements. And if we think about the whole atmosphere, it gets a little bit more nuanced. But here's a picture that might help us understand what's happening. In the atmosphere, we humans are, of course, releasing greenhouse gases into the air. Instead of labeling the individual chemicals, I've reorganized these data to show the emissions of greenhouse gases by the economic activity that's behind them. So we'll see words like electricity and food and industry and so on down below here. And we'll go back to that in a minute. But that's us on the left emitting pollution into the atmosphere. But the atmosphere doesn't sit still. The atmosphere has its own chemistry, its own physics. It interacts with biology across the planet. And some of those greenhouse gases, the part of the CO2 in particular, is removed by nature. It's removed by forest on land and oceans out in the open ocean, especially biologically productive areas and coastal areas. That leaves behind, though, about 60% of the greenhouse gases each and every year that stay in the atmosphere. Those then build up over time, causing the levels of greenhouse gases to go up. But we humans put in about 100 units of pollution, let's say. Nature is removing right now about 40 of them, and 60 are staying behind, causing climate change. To achieve drawdown, to stop climate change, we can work on both sides of this equation. But first and foremost, we must work on the left. There's really no substitute for reducing the sources of greenhouse gases ultimately to zero as quickly as we can. So we'll need to find opportunities to reduce those emissions from agriculture, from energy, from land use, from chemicals, from manufacturing, from all sorts of materials and so on. At the same time, nature can continue to remove at least a fraction of those emissions. As the absolute emissions go down, that fraction will also go in parallel with that. But we need to support nature as well. So nature can continue to remove some of our emissions through healthy forest and in healthy oceans. But without healthy forest and healthy oceans, nature can't do that anymore. So we need to pay attention to preserving and protecting natural sinks of carbon as well. So let's walk through those kind of areas. How do we reduce pollution, the sources of pollution, and bring them to zero? And then later, how can we work with nature to continue this kind of carbon removal that nature does for us? But to reduce the emissions of greenhouse gases, we need to really look at those individual source areas. Globally, these numbers, of course, would differ very much from place to place around the world, whether it's the United States, Saudi Arabia, Japan, Australia, Nigeria, they'd all be very different. But globally, about 1/4 of greenhouse gases today come from making electricity, burning coal and natural gas primarily to make electricity work. Interestingly, another 1/4 of climate change today, about an equal amount, is caused by the food system. So making electricity and making food are actually equally important to climate change, yet electricity gets a lot more attention. We also see industry is very important here, making different materials, things we use in the global economy, especially steel and concrete and plastics and so on, but also managing our waste streams. Transportation is very important, especially road and air travel and other things. Buildings matter quite a lot. And then the other last emissions, if you will, the last 10%, most of those actually come from the energy industry, refining oil or flaring and fugitive natural gas emissions and so on. But what's very interesting is the first 5 sectors, about 90% of global pollution come from just 5 things: making electricity, making food, our industries, transportation, and buildings. So 5 areas cover about 90% of the problem. And we can walk through each one and try to understand what we can do about it. As I said before, making electricity is about 25% of climate change, and we can look at making it in different ways. But we can also look at ways of using less electricity, being more efficient with our electricity sector as a whole. So whether electricity is made with fossil fuels or renewables, we could be efficient and use less of both and make the electricity system a lot more efficient. So when we think about electricity solutions in climate change, we can look at ways to use less electricity, primarily in buildings and industry, because that's where most of it's being used. And these little circles here represent different solutions that we've looked at to reduce emissions from energy efficiency in the electricity sector. On the same token, we can look at other ways of making electricity that don't require the use of fossil fuels. So we have things like wind turbines, solar, nuclear, ocean power, geothermal, biomass, and all these kinds of things. The size of the circle, by the way, represents what we believe is the size of the potential solution going forward into the next 3 decades or so. So the bigger the circle, the bigger the solution we think could be. When we look at food and agriculture and land use, those also total to roughly 1/4 of global emissions, a very large amount. And most of that is being caused by deforestation, is the first kind of cause. Second is methane emissions, mostly from animals. And third would be nitrous oxide emissions from overusing fertilizer and manure. Those are the kind of top 3 things to think about in the food system: is deforestation, meat and animal agriculture, and too much fertilizer use. Again, we can estimate the size of potential solutions because they're numerous. But one of the ones that's most exciting to me is addressing waste and diets in the food system. By reducing the 30 to 40% of the world's food that's wasted, we can attack a lot of these emissions, but also by shifting our diets to a little bit more plant-based diets, especially in rich countries, we can have an important impact on the food system as well. We also can further protect ecosystems from being cleared from deforestation and land clearing for food, and also then change the way we farm on the lands we already do farm. And so this kind of suite of changing diets, protecting ecosystems, and changing farming practices is very, very important. And there are a lot of things we can do here. Industry is also extremely important, as I mentioned before, particularly making metals like steel is a big emissions sector. Cement, as mentioned before. Chemicals, including making plastics. Plastics are about 1 and 1.5% of climate change today. Managing all of our waste streams, whether it's solid or kind of water waste, is very, very important here. These are very difficult to decarbonize sectors in some ways. These will probably be some of the hardest areas to work on for climate change, but there are numerous solutions here as well, and we can look at many different areas to do that. Transportation is also very important, 14% of the total, most of that on roads. So cars, trucks, et cetera, are probably the most important thing to work on here. But flying, rail, and ocean shipping are also important too. And then we get to buildings. Now, buildings are already kind of accounted for in terms of their electricity use because that's counted at the power plant. Also, the building materials, especially steel and cement and so on, are already accounted for in industry. So what we're looking at here is the last 6% of what buildings do. And that's primarily the emissions from the building's own envelope. That is like a furnace, a boiler, hot water heaters, leaking air conditioning systems, and so on. And those are very, very important as well. That totals about 6%, mostly in the residential building sector. But buildings have, again, a very important impact through electricity and through, of course, through industry. And the way we build things very much determines our transportation emissions as well. So the built environment is a very, very important part of climate change because it touches so many different things. We also then, once we can reduce emissions across electricity and buildings and transportation and food and industry, all of those areas, we have to reduce emissions greatly in those areas. We also can look at ways to support nature and support its so-called carbon sinks. Carbon sinks, or sometimes just called carbon removal, those are just things that take carbon out of the atmosphere, carbon dioxide in particular. And we humans keep on talking about this, but right now nature is doing basically all of this. Yes, industries around the world are trying to do carbon removal with machines, but even if those were to get 1 million times larger than they are today, they still would not be even observable in the atmosphere. They're too small, very, very small. All of the work right now is being done by land, forests growing a little bit faster than they used to, absorbing more carbon, and the oceans through photosynthesis and the carbonate pump and what's called a solubility pump, things that suck CO2 into the oceans. Now, down the road, yes, we humans can probably create more machines that can absorb carbon either at a power plant or a processing facility or what's called direct air capture. But right now, again, they're not even a millionfold improvement would not even make that big a difference right now. So this is a long way from being very practical. Right now, the big picture, though, is that we need to do a little bit of everything to stop climate change. We need to look at every possible way we can to reduce the sources of pollution in electricity, in food, in industry, transportation, and buildings. Fortunately, we have many solutions there. All the ones I showed you exist today and are economically viable right now. In addition, we have ways to kind of protect nature and maybe even augment what it's doing with planting trees and enhancing the way we do agriculture and so on, to not only preserve, but to increase the kind of carbon sinks across the planet that can help us also stabilize climate change. If we do these things, we can start to change the future, though, in very important ways. For example, we can see how greenhouse gases stabilize in a couple different scenarios, stopping climate change. For example, the red curve shows what we would do if we continue on the current path in starting the year 2022 and just keep going. The red curve is probably a good guess as to where greenhouse gases would go. But we don't have to do that. We can follow other trajectories, including those that stop climate change in as early as the 2040s, though that may be out of reach now, or through the 2050s into the 2060s. Those kind of scenarios are all possible between the green curve and the yellow curve, and between the yellow curve and the red one. Those are all still possible. If we did that, though, they would stop climate change at levels that are about 2 degrees or maybe 1.5 degrees of warming. Remember, we're already at 1 to 1.1 degrees of warming so far. So we need to stop this very, very soon to kind of keep climate change between 1.5 and 2 degrees. A lot of people, I think, would say today that 1.5 degrees of warming looks increasingly difficult to reach. But keeping the planet below 2 degrees warming, the original kind of Paris Accords target for climate change, is still very feasible if we get to work now. These are all things we have to work on, but time is the most important thing we have to do. What have we learned so far, though? What we've learned is it's not too late, and we actually do have enough solutions to stop climate change available today, and more solutions are coming every day. We can find all sorts of new technologies and practices that will help us, but we shouldn't wait because the ones we have now are very effective and can get the job started. Another thing we've learned is these solutions can also help make the world better. We can find better ways to power our industries. We can find better ways to build cities and power transportation. We can find better ways to grow food around the world and make the world not only better for climate, but better for a lot of things at the same time. But what we have to do now is really quickly move and scale what we already have. This is basically the graph that we have to pay attention to now. The red curve shows greenhouse gas emissions. That's the pollution we've already caused. The green curve below it would be the one where we can maybe remove additional carbon from the atmosphere, creating that blue curve towards net zero. But let's focus on the really important thing. What we mainly have to do is reduce emissions greatly by over 90% between now and 2050. To get there, to really get on that red curve where we cut emissions almost in half this decade, and then by almost 90% by 2050, we have to do the following. We need some very, very quick wins on reducing emissions right now. Things that we can kind of turn off that stop big emission sources, like stopping excess flaring of natural gas and fugitive emissions. Methane increases would be very, very important to focus on. Another area to be important to focus on, of course, is deforestation, because that's such a large emitter of greenhouse gases today, and it can be turned off relatively quickly if we choose to. Other kinds of emissions reductions, though, require a whole new infrastructure for the planet. New ways of generating electricity, new transportation, new buildings, new forms of agriculture. That will take time. We should start on that immediately, of course, but these kinds of things do take a natural amount of time, and that's something we have to be prepared for. We also can look at ways of removing carbon from the atmosphere, but we have to be careful to know that those take time as well. Planting trees today absorbs carbon 20 to 30 years from now, for the most part. It doesn't happen immediately. Same thing with soils. We have to know that there are slow kind of natural processes here that remove carbon. And of course, any new technologies that don't even really exist today or don't exist at scale may take decades to really unfurl and grow at the scale that we actually need. But to grow these solutions that we already have and take them to scale, we need not only the technology, we need the things that the levers, if you will, that scale them into the world and make them larger. Whether it's changing policy and the rules of law and regulation and taxes and incentives from governments around the world, that'll be very, very important. We need, of course, a huge infusion of capital in terms of public capital, private capital, and so on. We need changes in business practices that look at longer term goals and better standards. We need more technology, not just more technology as a whole, but more focused on immediate climate solutions that actually can work. And we also need to look at our own behaviors at the individual, community, and kind of national levels to kind of shift our norms and culture of, how do we behave and how do we interact with these systems? The good news, though, is that we get to reimagine the world here. We don't need to just focus on the bad side of this, of the challenges of addressing climate change, but also the opportunities it affords us. We have the chance to rebuild the world in ways that could be very, very beneficial to us in terms of new jobs, new opportunities, healthier, more secure countries, and making a frankly better world than we've ever seen before. So let me wrap up, and then hopefully we'll have time for some questions and conversation. But the most important thing I'd like to ask for you is to continue to do the job we all should be doing, which is to learn more about climate change and share what we learn. No one knows everything about this very complex issue, especially the solutions we need. So we need to learn and share everything we can with everyone we know. And finally, to remember that the future is not entirely written yet. Sometimes it feels that way with climate change, that it's too late to do anything, but that's not really true. The future is still up for grabs. Yes, we've warmed the planet some already, but whether we continue to do that or not is up to us. And what kind of future we leave our next generations is still up to us. So remind yourselves that the future is up for grabs, and it belongs to the people who take the risk and accept the responsibility of consciously creating a future that they want. So with that, I'll stop this presentation and hope to turn it over to the moderator for some questions, and hope to continue the conversation with you here. So thank you very, very much.
Thank you, Dr. Foley. We are now opening the floor for questions from our audience joining us here in the auditorium and also online. You can use the microphone in the aisle to make your questions. We have already lined up some questions online. I will start by the first one, Pedro Cardoso. Some environmentalists say that it's impossible for economies to expand infinitely in a world with finite resources, limited resources. Do you believe drawdown can still be achieved while world economies try to expand infinitely?
Yes, I do. I think there's a potential to, we've already seen some decoupling of economic growth and the use of fossil fuels and the growth in greenhouse gas emissions. We've demonstrated that it's possible to still have economic activity and growth that uses less resources than we've used in the past. That's what we'll need to do. I know that but we also need to, well, I don't think it's that simple to say it's either we continue to grow the economy the way we've done it, or to abandon kind of any economic growth. I think the world will be somewhere in the middle, where we need to rethink economic activity so that we use less resources while still promoting economic activity. But then maybe we measure economic activity in ways that are a bit more meaningful. Instead of just measuring dollars, for example, we really look at the economic engine of our planet and look at the human well-being that it produces. I would rather measure economic activity as like how many people live good lives, how many people are healthy, well-educated, have good basic rights, are getting good material support for what they want, not just the number of dollars flowing through bank accounts. So I think we need to rethink the economy a little bit, of course, but we also can grow the economy however we measure it, whatever metrics you use, in ways that use fewer resources. We have the opportunity to build a very robust world in front of us that's more fair and more just, but also much cleaner and much more resilient than ever before. And those things will be very important to do together.
Thank you. We have another question from Urbano Medina. Dr. Foley, what are your comments on the feasibility of the implementation of green fuels, such as hydrogen and ammonia obtained from renewable sources? E-fuels are way more expensive than their contravariants, not to mention all the challenges related.
Well, yes, of course. There's a lot of interest, of course, right now in using alternative kind of fuels. Batteries, of course, will be one that we'll be using for a lot of things now. Those work very, very well. But in terms of like liquid fuels or compressed gas fuels like hydrogen or ammonia or things like this, yes, they are more expensive to produce right now, but that's probably a temporary phenomenon. We really won't have any choice. So we need to kind of find ways to make these fuels that are truly, truly sustainable and climate beneficial. For example, in hydrogen, there's a lot of debate about the different kinds of forms of hydrogen. Whether or not they're really a distraction or not. But it is possible to make hydrogen with completely green hydrogen that's powered entirely by solar or wind or something like that. And those will probably have some important niche applications. But for transportation and buildings and so on, I think it's hard to imagine anything more efficient than batteries we have today right now, or future battery technologies will probably play a very important role. So these other kind of alternative fuels for things like maybe aviation, a few other kind of hard to decarbonize sectors could be very important, some industries as well, but they're much, much smaller than today's traditional petroleum fuels.
Thank you. A lot of questions now. Nora's Daramek. Often business monetary solutions are proposed to fight climate change. Do you think significant solutions may be achieved in a market profit-based system? Do we actually need a transformation of our socioeconomic system away from capitalism?
Well, I'm a scientist. I'm not qualified to judge that statement very well, but I think it's probably a lot easier to change capitalism so it doesn't emit so much CO2 than it is to change the world from its current political economic system to an entirely new one. That seems much, much, much harder than changing the technologies that power the current system. Is a lot easier. We know how to do it. So I don't know if it makes sense to say the only way to address climate change is to throw away capitalism and democracies around the world the way we currently see them. But maybe they could be a little bit of both. We change the way we power capitalism and our current economic systems, but also maybe rethink them a little. Hopefully we can do a bit of both and make a wiser and more fair and sustainable planet. But the fact is, what we need to do to address climate change is relatively simple. We stop burning fossil fuels and power our economy with different things that we already have. There's nothing here that needs to be invented. We already have all these tools. We need to be so much less destructive with our land use. We need to be more thoughtful with materials. We need to be pricing things so that they reflect their real cost, not their just initial cost, to us and the planet. There's nothing we need to stop climate change that we don't already have. Now, of course, more technologies, more inventions, more even policies would be helpful, but it's mainly been kind of political and economic forces that have kept us from achieving kind of stopping climate change. So I don't know if overthrowing capitalism is the only way forward. That seems like a much harder thing to do than fixing the system we have today, which we've known how to do for 30 years. We just haven't done it yet.
Thank you. Now we have a question very specific on buildings. Fabio Camargo is asking, in a building, when we compare insulation promoted by a green roof versus energy generated by a solar panel, which one you think is more effective to assist drawdown?
Well, the answer, unfortunately, is, well, it depends a lot on the local conditions of where the building is. So in some places, the green roof might be more beneficial than having solar panels on the roof. And a lot of places also you find the economy of scale. It might be better to put solar panels not on the roofs of individual buildings everywhere, but maybe in large kind of fields, depending on the land use conditions, where you can get an economy of scale of kind of utility scale solar production. So I think the answer would be a little bit of both. We need kind of green roofs and white roofs, things that don't heat up so much during the summers and hot conditions. But at the same time, we do need massive increases in solar production as well. So this situation would probably be very much dependent on where you are and what the kind of heating and cooling needs for the building would be in that particular climate and that particular location, as well as what the kind of energy economics is for solar in that particular place. So I'm afraid there's no one answer to that. So they're two good tools to use in very different situations.
Mashadix is asking, you showed predictive models of carbon in atmosphere following different scenarios of action, business as usual, etc. Do these consider effects of irreversible tipping points, large predictive releases of methane once Arctic permafrost thaws?
The ones I showed do not, but most climate models do include those kinds of feedbacks. And for the most part, those tipping points are not really tipping points. That's an area I used to work on a lot. They're actually much more gradual than you think. There's not like a point where we hit a certain threshold and all of a sudden climate change becomes irreversible. That's not really how climate scientists think about this. What happens is, as the planet warms, there are feedbacks that make the warming larger than it would have been by some percentage. But it's not like it's going over a cliff. It's more like you're going down a hill that's maybe getting steeper as you go. And that's the danger we're in today. So yes, the models that predict future climate change include what we know, at least, to be the kind of feedbacks from snow, from ice, from the oceans. There's very little evidence right now that methane emissions are increasing from nature. Methane emissions are increasing from humans, that we do know, and that's the real problem. But the kind of feedbacks of methane from the Arctic, most scientists believe that that's not really a huge issue today, but it's something we need to keep an eye on. So very good question. There are concerns about, kind of additional feedbacks. But I think a lot of them, as reported in the media, are not really the same as what scientists are looking at as a whole. But we need to keep an eye on the entire space, because obviously that would be a very, very serious concern. The best thing we can do is stop warming as soon as we can to avoid any potential for going over those kinds of tipping points, even if they do exist, or even if they're worse than we imagine. Of course, we want to avoid them.
Thank you. Now, another question is changing, and how is the recyclable waste originating from solar panels, interesting one, and fiberglass blades accounted for in the long run if they become quickly and widely disseminated? Can we be solving one problem with another? I think we're creating another.
Yes, I mean, that's a very good point. But the current system is far more wasteful. The current use of materials, energy, and so on that we have today is ridiculously wasteful. If we think about the food system, for example, 40% of all the food grown on the planet is never even eaten. Something like 70% of the energy used on this planet actually does no useful function. It has lost its heat out into the universe. That's crazy. Same thing's true with other materials today, whether it's steel, concrete, pipelines, electrical wiring, and all the things that power our current economic system are also incredibly wasteful and produce lots and lots of problems. We also, use a lot of the same materials today. Like we already use a lot of batteries, even before electric cars and solar panels. Largely they're in these things or laptops or other consumer goods. We already have to solve that problem anyway. So battery recycling will be a very important thing to focus on, but we already need to do that anyway. Same thing with solar panels. Those actually, they'll last a very long time, 30 to 50 years, and have been shown to be fairly straightforward to recycle, and they're all identical, and they don't fail quite as quickly as a lot of other infrastructure. So solar is actually one of the best things in terms of long-lived infrastructure, requires very little maintenance, and is relatively easy to recycle, not completely, but can be. So yes, those are challenges, but the current economic system is much worse than almost anything we're imagining to address climate change. So it's not that we, only because we're addressing climate change, do we have to think about recycling kind of difficult materials, including those things in batteries or solar panels. We've already had to do far worse than that today with the current economic system. So this is not a new problem, and it's one we'll have to address in either way we go.
Thank you. The questions continue to come, and they're very interesting. Long list. I will pass now to another area, which is very interesting. A question that we have here: what do you think, from Nawader Al-Qadi, what do you think may contribute to achieving an effective solution to climate change at the individual level?
Well, as individuals, we can only do so much because our influence is limited to the world kind of near us. But that is considerable. The one level of things that individuals can do, of course, is for individual actions with respect to energy, food, materials, and things like this. In the United States, for example, where I live, it's estimated about a third of climate change kind of solutions are really affected most by what individuals and communities do. So that's important. That number may be similar in other parts of the world as well. So things like reducing food waste, making sure we don't throw away as much food would be very, very helpful. Second would be changing our diets to be less red meat, for example, is very important in many parts of the world. It wouldn't work everywhere. I'm not saying everyone should do that, but in some places it would be very effective. Other things like energy efficiency, the kind of choice of vehicles we have in the future. When you have those critical purchasing decisions of buying a home or apartment, buying a car, things like this, to look for the most efficient and kind of greenest options possible at those times is very, very helpful. So yes, we individuals exercise a lot of influence that way in our everyday decisions. But also we are part of societies that have politics, that have financial systems that we can also participate in by voting, by engaging in our politics, to kind of put climate issues into the political discourse more and more. That's, of course, very important. Also, how we spend and invest our money personally can be very important as well. Whether we say, no, I want to put my retirement savings into those kinds of funds that maybe invest in better, greener technologies as opposed to other things. Or which banks you use, that kind of thing. Those are all important decisions that we as individuals can help make. But most important is to continue to talk about climate change and share what we know with other people. Again, no one has all the answers, but I think together we can find many more good ideas and share them with the world and excite people about seeing climate change solutions as an opportunity to build a better world. Not just as something to fear, but as something to look at with the idea of opportunity and abundance and how we can build a better world together. Those are all things we can all contribute to in small ways and maybe some large ways. And we desperately need that kind of leadership from all of us.
Yeah. Thank you. I have now a provocative question. Do you think the enforcement of better environmental regulations, even by force if needed, and implementation of harsh penalties is more efficient given that many individuals and corporations aren't motivated or convinced by science?
Well, again, that's probably out of my area of expertise as a scientist, but we do have laws already for many things that are considered bad behavior. We have to pay our taxes, we have to not steal, we have to get along and not hurt each other and all these kinds of things. So environmental laws and regulations can be helpful as well. So far it's been difficult to pass kind of meaningful climate laws that have more penalties related to climate. So we've used more kind of the incentive-based approach with like tax breaks, incentives, encouragement for markets and technologies, and kind of the public sector and the private sector to kind of move forward more voluntarily. I'd like to believe that climate change solutions are not just something that should be forced on people, but they're so good for us that they build a better world with more jobs, more security, cleaner air, and kind of a better future, that people will be looking to embrace them as ways of moving forward. Electric cars are actually a lot more fun to drive, and a more sustainable agriculture can produce healthier food, and more sustainable cities are better to live in. There's a lot of good reasons to embrace climate solutions that go beyond just the greenhouse gases. They generally work better, and they can involve better technologies, and they can be designed to make a better world around them. So like anything in the world, I suppose we need some kind of, like they say, carrots and sticks, both kind of in things that encourage behavior that we want, and of course things that discourage behavior that we don't like as a society. But that's for all of us to decide. That would not be wise to just have environmentalists make all the rules, or scientists or anyone. We need to think about this together collectively as a society of what it means to be fair, what it means to address a critical issue that affects all of us. And to do that with some wisdom moving forward would be very, very critical. We seem to have had a difficult time doing that as a planet so far, but I have hope that we can rise to that occasion, and we'll do so soon.
Thank you. Now, Mohammed Al-Saikin, bringing an very interesting question. Overpopulation seems to be one of the elephants in the room that are not broadly addressed globally when it comes to the efforts to reduce waste and emissions. How do you see policies like the one-child policy play into the climate change issue?
Yeah. Well, the fact remains that two things are very important. First of all, most of the greenhouse gases emitted in the planet today are not emitted by many people. They're emitted by a very small fraction of the world's population, mainly people in very rich countries that have used a lot more resources. So population growth is not not really a driver of climate change directly. It's mostly the economic growth, especially the top 10 to 20% of the world's population emits 80% of the greenhouse gases, let's say. So population itself, the growth of global population is not really what's driving this issue directly today. The second thing that's very interesting is population growth is slowing down faster than about anyone ever predicted. The official UN projections still show populations heading towards 10 billion. Most people, though, work in demography that I know, don't believe that's ever going to happen. And that will probably stabilize between 8 and 9 billion, somewhere in there, which is very different than the world. When I was a student, people were talking about 15 to 16 billion later in the century. That is mathematically impossible today. So population growth, first of all, is slowing. And second of all, is not really the driver of most of the emissions. So it is important for many other reasons, but most of all, I would think it's probably more important to think not only about population growth as a number, but rather the people in the systems with growing populations about what is the status of women, what about human rights, health, things like that. That's a much more important question than just the sheer number of people in the world, I would suggest, but also the choices that people make in the future and the kind of very complex cultural, legal, and ethical dilemma of how we think about human rights and growing population. But the math tells us that the emissions don't come from the growing populations of the world. They come from rich countries in the world mostly, at least right now. And the population as a whole globally is slowing down very, very quickly, much quicker than anybody suspected. And so that we have to rethink the whole thing. It's not as simple as just growing population means worse environmental conditions. It's a little more nuanced than that.
Thank you. Now, João Cruzado is asking, any thoughts on the ocean circulation path or changes that might be heading for collapse due to climate change, extreme cold to Europe and North America, and several other changes throughout the world?
Yes. This has received a lot of attention in the media, as it should, but it's also been a little bit overhyped and maybe misinterpreted somewhat. As the oceans warm, in the North Atlantic, for example, there is a what is called a thermohaline circulation. It's just a fancy word for cold, salty water sinking down below in the top of the kind of North Atlantic near the Arctic Ocean, in what's basically the Norwegian Sea and the Greenland Sea. And that water that sinks kind of spreads out down into the lower Atlantic, down below the surface waters, and kind of completes a very long-term kind of overturning circulation. Interestingly, in the Pacific Ocean, there isn't one of those. The ocean water doesn't sink the same way it does in the Atlantic, and the Pacific still works just fine. This is very interesting in that with climate change, that kind of underwater kind of, the deep ocean circulation, that thermohaline circulation may slow down. Some people suggest it may even stop. That does not mean the Gulf Stream stops, by the way. It does not at all. The Gulf Stream will continue, just like there's something called Kuroshio current in the Pacific Ocean. As long as the Earth rotates and winds blow, there will always be a Gulf Stream on this planet. And this will not radically change all of the North Atlantic's climates, by the way some people have suggested in movies and other things. But it would have a pretty important effect off the coast of Greenland, perhaps as far south as like Scotland and places like that. It could have a pretty significant effect on temperatures there, making it cooler than it otherwise would be, but combined with a warming world, so it might actually cancel out a little bit. But it could also have kind of trickle-down effects in terms of sea level rise as far south as the North American coast along like Newfoundland into New England in the United States, for example. It could have important shifts in how sea levels rise through there. So again, it's very, very important, but it doesn't mean the Gulf Stream is shutting down the way sometimes it's reported in the media. That's not true. And it would be an important regional effect in the Norwegian and Greenland seas with trickle-down effects through the Labrador Current into like southern Canada, northern New England, for example. So very, very important, something to watch very carefully. But I'm a little bit worried that sometimes in some news reporting, it's kind of described as this, shutting down of the Gulf Stream, and that's not what's happening. It's a little more complicated than that. But whether or not this even happens is still debatable. There are some observations that suggest that there is a slowing down of that current in the deeper oceans right now, but it's very, very difficult to measure, as you might imagine. So to be honest, it's something we just have to keep watching and be ready for. And it might happen, it might not, but it's one of those kind of threshold events that we worry about with climate change. As the planet warms, things will change in ways we've never seen before. And some of those might be effectively irreversible and have some pretty big consequences. I wish I had a better answer for you, but we'll have to see, is the answer, like a lot of the science.
Unpredictable, yeah. Another question. Do you think that would still be possible to shift to renewable energy sources with an overall negative carbon footprint? So far, the production of batteries and catalysts still use non-renewable energy sources. Do you have any time frame?
Mm-hmm. Yes. Well, compared to the systems they replace, they are very much carbon negative, if you will. They use a lot less carbon than would have even used for the same thing. Like building an electric car over its lifetime uses far less energy and resources than building a petroleum-based car, even with the batteries and everything else. Because remember, the things we're building for renewable energy and things like this are simply replacing systems that also needed to be built. It wasn't like oil and gas and coal were just sitting there already there. We need to continue to build power plants and things like this, regardless if they're renewable or not. So you have to look at the difference between the world we would have had and the world of renewable energy and ask what that difference is. But yes, the important point is that even then, right now, solar panels are, for example, aren't built usually by factories powered by solar panels. Someday they will be, but right now we're still using some fossil fuels to build the components of the renewable energy world that we need, like batteries, solar panels, wind turbines, and so on. But those can be powered, of course, by things like renewables themselves, or nuclear energy, or other things, and eventually they will be. Sometime, and it's a very safe bet that most of the electricity in this world will be produced by renewables in the next decade or two. And pretty much the entire energy sector will have to change, and it will. So that's probably inevitable. Just when is the question, not if.
Thank you. There's so many questions, and we are almost finishing our time. We have an interesting question here. Do we expect ourselves to live in another planet as a solution?
I don't. It's hard enough to just modify our own economy here and get it to work better. What it would take to be a viable biosphere on another planet, I think, is so far beyond our understanding, let alone our technological reach. And let's be honest, right now our spacefaring technology is limited to maybe going to a little hotel in orbit and coming back down again. And we've been doing that since the 1960s. I know it's exciting that the private sector is now doing what NASA and the Soviets were doing in the 1960s, but there's not really a fundamental shift in this kind of thing. The idea that we're going to live on Mars, I think is fantasy for at least the next 200 years or something. And why? We have a perfectly good and beautiful, amazing planet here. I would much rather focus our attention on fixing that and doing better here than kind of a fantasy of rich people moving to Mars. I don't know anybody who's very credible believes that's going to happen in any meaningful way. And even if it did, it would use so much resources to get there and just further doom this planet to a world we don't want. It's far, far better to just accept the science and the reality and and be a little more humble, I think, and say, look, this is a beautiful, amazing world that's sustained every human who's ever lived before us, and every human who's ever going to live after us will live on this planet. So let's make it a good one, and let's make better choices, be a little less selfish, be a little more foresighted, and let's use the tools we have today to make a better world that's greener and fairer and kinder and more sustainable for us and for future generations. It's entirely doable. We just have to make the choice of what kind of world do we want, and I think we can choose a better one.
That's a great way to finish today. It's a very positive message. We need this message to continue and to actually drive the change. Our time is over. Thank you so much. I would like to thank Professor Jonathan Foley for joining us today and sharing with us a remarkably inspiring work on the project Drawdown. And we look forward to welcome you in person in KAUST, hopefully very soon. Thank you so much.
Yes, looking forward to it. Thank you.
What we see normally in academia is all the publications, all the experiments that did work, but you never see all the experiments that didn't.
Here I'm sharing my story in developing COVID-19 diagnostic kit based on PCR and RT-PCR technologies. People wanted to hear on how we have dealt with all these milestone and failure, and we've shared it with them, and it was really great interaction.
I got funding for exactly a year, right in the middle, COVID started, and kind of put a halt to all my research. I wanted to kind of inspire the students and researchers that have also faced these setbacks.
We actually want to send this message out. You will actually fail, we know that, but learn from that failure and build resilience mindset. If you do that, then you become stronger.